Hey guys, Mr. Raider here. We got another episode of the Math6. Worksheet number 3. Let's get right into it. So, pre-algebra, complex fractions. This one's no easy task for a middle schooler, so if you're watching this, you're definitely going to get ahead here. Unless you're in a really advanced class. So, in order to do this, we see fraction minus fraction over fraction. Okay, so we got a lot of fractions here. We hate fractions. The way we can kind of get rid of them is if they all have the same denominator. So we're going to look at 4, 2, and 8 all at the same time. So what can all those become? Kind of like if you saw all those fractions, like what would be the same denominator, the same bottom? 8 should kind of get to your head. All of them could become an 8. That being said, we can multiply this one by 2. Whatever you do at the top, do at the bottom. 2 times what is 8? It's 4. And then the bottom one, we really don't have to times it by anything because it's already 8. So after that, let's see what happens. So the first fraction, 3 times 2 is 6. Over 4 times 2 is 8. Good. Minus, let's do the next fraction. 1 times 4 is 4. 2 times 4 is 8. Over the next, this one didn't even change. 1 over 8. Very good. And then when you see that, we can basically see that there's an 8 on the bottom everywhere. We can basically just get rid of the bottoms. It's pretty cool. So what we have is 6 minus 4 over 1. So the answer is 2. That was a good question. Okay. There are other ways to do that. That's probably the most, if you're... That's good for everyone. That's a good way for everyone. That's all I got to say about it. And that's how I'm going to try to do most of these problems. The good way for everyone. Algebra 1, absolute value equations. This is such a good question because everyone forgets it after they learn it, like months after. So it's always good to see this one again to refresh your brains. So in order to solve these, we got an absolute value house. In order to solve these, we got to get the house by itself. This is the house. I call the absolute value bars the house. So we're going to get that by itself. First thing to do is subtract the 3. Boom. It's easy enough. Copy, copy. That's 12. And now, I got to get the house by itself. Still not by itself. See that 2 right there? Divide by 2. So just easy algebra right here. So we got the absolute value of something, x minus 4, equals 6. The objective complete. We got the house by itself. There it is. So now from here, we're going to create 2 different equations. We'll call it the A equation and the B equation. The A equation is to do exactly what we see without the house. X minus 4 equals 6. The other equation, you copy the x minus 4. But you reverse the 6. It's not 6, it's negative 6. There you go. Solve these baby equations. Plus 4 on both sides. X equals 10. That's one answer. Add 4 on both sides. X equals negative 2. And there's my 2 answers. X equals 10. X equals negative 2. There are 2 answers for those, mostly. There are instances where you could have 1 answer, or actually no answers. We'll talk about that another day, probably. Alright, that was our Algebra 1 question. Ooh, geometry. By the way, I'm going in these questions blind, so if I take a minute to think about it, it could happen, especially that SAT question. Area of a shaded region. A circle is inscribed inside a square. There it is. Find the exact area of the shaded region. Leave your answer in terms of pi. Okay, so the shaded region's like this squarish, the outside the square, the circle, outside the circle area. So they want us to find like this part. So from what I'm seeing, we definitely should find the area of the outer, which is the square. So imagine finding the area of this square first. And then we should subtract the area of the circle, which is the inside. So we're going to find the area of the square first. If it's a square, that means this is also 8. If you ever see a box figure, it's just length times width. So 8 times 8 is the area of the square, which is 64. So big square 64. Now, how in the world am I going to find the area of the circle? Well, I need the formula first. Area circle is pi r squared. Well, I need my radius. This is a little tricky. So the diameter of the circle is the same size as the side of the square, which is 8. Which means half of it is the radius, which is 4. So we have the radius. Radius is 4. So I'm going to plug that in right here. So I'm going to put the 4 in where the r is. That means area square. So 4 times 4, 16 pi. So that's the area of the circle. So like I said, square minus circle. This was the area of the square. So 64, that's the square, minus the circle, 16 pi. They did want us to leave it as that. If they see how they said leave your answers in terms of pi, that's it. You can't really make that look any better. You could, if they asked for like rounding in the calculator, you would just put all that in the calculator and say what the decimal is. Okay? Exact answers are always, you leave the pi alone. Alright, cool. Technically, it is an area, so you could say units squared. Some teachers are picky about that, some are not. Cool. Algebra 2, log equations. Okay. This is the famous log chapter. A lot of people don't do good on this test because a lot of people, from my experience tutoring, they'll it's been easy up to this chapter, and then they'll think it's easy, and then it just smacks them in the face. So watch out for this one. Okay, so we got a log equation. To do these, there's a lot of ways it could look. To do this one, we want to condense this so that we can make it into exponential form. So the rule is we can basically combine these logs. So you copy the 2. And then because of the adding, it's going to be multiplying. So we're going to multiply these. Okay. Equals 3. So that was like going really slow. So that was it's called condensing logs. So these 2 logs turn into that. We could distribute that x right now. Why not? Let's just get it out the way. So if you distribute the x, that's x squared minus 2x. That's this thing. Algebra 2, you probably know that and easily. Technically, a parenthesis here looks better because it's 2 terms with the log. And now we're going to change it to exponential. So to change things to exponential, why do we have to do that? It's because we kind of feel stuck. The x is inside the parentheses. It's inside the log. We feel kind of stuck here. So the only way to get the x out is to do this. We're going to write, you start with the 2, big 2, exponents 3, 2 to the 3rd equals, and we're going to copy the x squared minus 2x. There it is. And then 2 to the 3 is just 8. And then look at this. We got an exponential on the board, a squared. When that happens, we need to make it equal 0 because we're about to do the big X, or factoring. So we're going to subtract the 8 to make it equal 0. I'm not going to show all the work because this is algebra 2, remember, so, subtracting the 8 should be a piece of cake nowadays. We're going to do the big X. We did this on one of my other videos. This is an easier one. Multiplies to negative 8, adds to negative 2. It's negative 4 and 2. So we have x minus 4, x plus 2. Set each parenthesis equal to 0. X equals 4, x equals negative 2. Now, because it's log, we have to check for something called extraneous. What's extraneous? So basically, you got to make sure when you plug these answers into the very beginning that we don't get a negative inside the log. Because, like, for instance, I'll do an example. Like log 2 negative 5, so see how that's like a negative number? That is extraneous. That can't happen. Like it's no solution. It's illegal. So if we plug in 4, that's okay because it's a log 2 4. Positive 4, that's fine. This one would be 4 minus 2, which is 2. That's fine. So 4 is good. But if we plug in negative 2, watch what happens. Log 2 negative 2. Already that's bad because you can't have negative inside the log. So this is called extraneous. And you don't really need to know the word extraneous, but it just means that like this is not an answer. So the only answer here is x equals 4. And that's it. That was a long one. This problem could fall into pre-calc as well, by the way. That's a pretty tough algebra 2 problem. All right, what do we have here? Rational functions. Been doing this all year. Identify the x-coordinates of any vertical asymptotes and holes. Only x-coordinates. That's nice of them. So they want holes and vertical asymptotes. I'm going to call that VA. Okay. So the first thing to do is to factor the top and bottom as much as possible. So the top we could do, this is the special one. Half my students always forget this. It'd be nice if you didn't at some point. I know my pre-calc students have seen that somewhat before. That's it. Now we could factor the bottom. This should be easy for you by now. I'm just going to speed it up. It's just an x squared. So we got x minus 4, x plus 3. So this is completely factored. Now, we are going to see if anything cancels out. I see the x minus 4. Those cancel out. That means you set it equal to 0. So we got x minus 4 canceled out. Set it equal to 0. That means x equals 4 is a whole. Okay? There's a way to find the coordinate, but they don't care about that, so we're not going to do it. But there's a hole at x equals 4. Now we're just left with our, we're left with what we're left with. So we just have x plus 4 over x plus 3. So we could we only have to look at this now. So we took the hole out. And to find vertical asymptotes, you set the bottom equal to 0. So the bottom is x plus 3. Set it equal to 0. That's the VA. And that's it. These are both the answers. Let me make sure I answer what they wanted. Identify the x-coordinate of any vertical asymptotes and holes. Done. Very good. All right. Now for the last one, SAT. Ooh, this is a good one. The equation of a circle is given below. What is the radius? Ooh, this question's always a toughie for some people until you practice. So this is completing the square on steroids. They already did a hard part, or not a hard part, but the first step. This number can't be on this side. So they already put it on the other side for us. So we should only have x's and y variables with their coefficients. What we're going to do right away, we're going to deal with that one first. You just automatically write this. There's like a way to do this that's more, I guess, more answers like why. The way I do it is just more like, hey, just do this and get the answer. Like, that's what I'm trying to do here. So you automatically, like, when you see this, you just automatically do that. It's going to be the same thing. You just write all that. Let's change color. Now, what goes here? You're going to divide the number with just the x by 2. So 8 divided by 2, positive 4. Boom. We're going to do the same thing here. Divide the negative 6 by 2, minus 3. Then you're going to square the number we just put. So we have two numbers. We're going to square the 4. That's 4 squared is 16. You add it here. Negative 3 squared, always positive, okay? So negative 3 squared is 9. Add the 9. Bam. Okay, I might sneeze. And then we're going to write what we have, clean it up. So we're going to copy and paste to the left. All that equals, let's do some mental math, 49. There it is. And the radius comes from this term. So the circle formula, this term right here is actually r squared. So the way to find the radius is you could just square root it. Done. The radius is 7. Now I'm just dying since we got so far. If the question asks for the center is just these but reversed. So negative 4, comma 3. So that's the center of the circle. Both are great SAT questions. They probably would have asked for both at some point. But for this question, radius is 7. Alright, that's it. If you liked the video, like, comment, subscribe. Look in the description. You could sign up for the email for the PDFs. And they'll be all time stamped with the videos and solutions. Thank you so much. Have a good one.